Welcome back to Chemo Notes, your chemistry companion for clearing concepts and smart learning. Today, we are going to study about the most important and frequently asked rearrangements, the Pinacol-Pinacolone rearrangements. This is a remarkable beginning for our organic rearrangement series where we'll break down each reaction step by step with mechanism, tips to remember, and exam focused insights. So grab your notebook and let us start the fantastic rearrangement reaction, part 1. So let us start our rearrangement series with the first one, that is Pinacol-Pinacolone rearrangement. So here in this rearrangement, 1,2 diols, or they are also known as vicinal diols, are treated with acid and rearrangement takes place. The diol is transferred into ketone. So basically you will find that the diol is converted into ketone. So let us see. This is the diol which you can see here, which is also known as Pinacol. Okay. So 1,2 diol is known as Pinacol. So you will find here, if we start numbering them. So this is your first carbon and this is your second carbon. So on first carbon there is OH group and second carbon also there is OH group. And there are 4 R groups, those are substitutes on first and second carbon. So it is 1,2 diol. So when it is treated with acid, acid contains H plus ions. Okay. So this Pinacol undergoes rearrangement to form ketone, or which is also known as pinacolone. So see here what has happened. One of the OH is removed and it has been converted into carbonyl group, whereas one OH has been eliminated, hydroxyl group, one hydroxyl group, or in short, if you see the complete molecular formula, you will find that Pinacol has converted into pinacolone. Colon is one is there, means ketone. Okay, and there is removal of water, elimination of water group. If you find OH and one hydrogen has been removed and remaining atoms are there in that molecular formula. So let us see how this conversion or how this rearrangement takes place. So here, before we see the mechanism, please understand these R groups may be different or may be same. For example, we have taken here, this is 1,2 diol, where you can find all the substitutes are methyl groups. So if you actually label it by IUPAC, you will find that it is 1, 2, 3, 4. The longest chain is 4, 4 chain carbon, so it is a butane. Parent alkane, parent group is buta. Okay, 1,2 diol, or butane. Then you can, if you are writing in terms of butane, then it is 2 and 3, 2, 3 diol. Okay, buta 2, 3 diol. So this way you can label it, or if you don't want to label it, just you can write vicinal diol, 1,2 vicinal diol. Okay, so here all the groups, R groups, are CH3 groups. When it is treated with your acid, it may be con acid. Okay, what has happened is removal of water group and it has been converted into ketone or pinacolone. So it is pinacolone. Okay, so this way the conversion takes place. Very simple reaction, very simple rearrangement. Now we should understand how the rearrangement is taking place. One of the R group, if you see here, one of the R group has transferred or rearranged to second carbon. Similarly here in this example, one of the CH3 group has been transferred to the second carbon. You will find here 1, 2, 3. Okay, so there are 3 methyl groups on second carbon. So this way the change happens, that is rearrangement takes place in 1,2 vicinal diol, and we are getting pinacolone. So let us see the mechanism, how the change takes place step by step. So basically Pinacol-Pinacolone rearrangement takes place in 3 steps. First step is formation of carbocation. Okay, so let us take a pinacol, that is 1,2-diol. Here we have taken the same example which we have shown in the previous slide, that is butane 1,2-diol. So here in butane 1,2-diol you will find that first step is formation of carbocation. Okay, so let us see how the carbocation takes place. So before formation of carbocation, basically the acid, when we are treating with acid, protonation takes place. What happens is protonation takes place. So your OH groups, because they carry lone pair, 2 lone pair, okay, one of the OH group is going to grab the proton. It is going to grab the proton, and there is hydronium ion which is formed. See here, hydronium ion is going to be formed. So first step is protonation. So when you have protonation, then you will find it gets converted into carbocation, that is elimination of water molecule. So here what is the second step which is going to happen, because oxygen has used its electron pair to grab the proton, so it will carry plus charge. Okay, students, the electron pairs were used by oxygen, and that's the reason it will carry plus charge here. So when it is going to carry plus charge, obviously it has to neutralize those charge which it is carrying. So what is going to happen is elimination of water molecule will take place. Elimination of water molecule. Okay, so when the water molecule will eliminate, carrying those electrons of the bond, it is going to form a carbocation. The step 1. Step 1 is formation of carbocation. So here is the carbocation which is going to be formed. Okay, so the thing is, first what we did, the diol got protonated, then elimination of water molecule. So here it is elimination of water molecule. Okay, now after formation of carbocation, there is rearrangement which is going to take place, that is this. Okay, rearrangement is going to take place where 1,2 shift is going to take place. Okay, how the rearrangement is going to take place, the shifting is going to take place, that is 1,2 shift it is called. So as we have labeled this OH groups as 1 and 2. So you will find that first and second there is going to have a rearrangement or shifting going to occur here. So all the substituents on first and second carbon are same, that is methyl group. Even in the exam you will find that they may give you Me instead of CH3. Okay, Me indicates methyl group. So all the groups are methyl group. So it doesn't matter whichever group gets transferred. So let us see that this is the methyl group which is going to transfer here. Okay, or shifting will take place from first carbon to second carbon. That's the reason why it is called as 1,2 shift. So when this methyl group gets shifted, this is what you are going to get. Okay, now this shifting will not occur on its own. What is going to happen is the electron pair, how the mechanism takes place, the electron pair of oxygen will shift here, and it will push CH3 to go on the carbocation which has formed to neutralize it, neutralize the plus charge. Okay, so this is how you are going to get oxygen double bond. Then oxygen has used its electrons, so plus charge, oxygen will carry plus charge. Okay, now to satisfy that plus charge, what is going to happen, there is removal of proton. This proton which is there, this proton will give its electrons and it will go away. Okay, so the third step is loss of proton. So here minus H plus you can write. There is removal of proton. Now when the proton is lost, it has given its lone pair to the oxygen, and that's the reason why oxygen will again get its lone pair. Okay, it's lone pair. And this way what we have done, we have prepared a pinacolon, that is ketone. So in three steps the reaction mechanism goes. First step, formation of carbocation by protonation of one of the OH group, then elimination of water molecule, then shifting takes place, that is rearrangement, 1,2 shift takes place, and last step is removal of proton or loss of proton to give pinacolon, which is also ketone. If you see here R group, okay, there is R group and there is R group here, and in between C double bond O, carbonyl group, so it is a keto group. And this way the Pinacol-Pinacolone rearrangement takes place. Now let us see some of the important factors which you should know while undergoing these such type of. So let us understand why the rearrangement takes place. So basically rearrangement takes place only if the resulting carbocation is more stable than the original. Now how you can guess which carbocation is more stable? Okay, so first of all, whenever we are forming a carbocation, you should try to find out which one among the two, that is first carbon or second carbon of the diol, is going to be more stable. For example, you can see here there are three carbocations I have shown here. Okay, so first carbocation, there is only one substitute, that is, let us say R1. Then in second carbocation there is R1 and R2, and in third carbocation if you will find there is R1, R2 and R3. Three alkyl groups. So R indicates alkyl groups. Okay, R is nothing but either alkyl or aryl groups. Followed? So here among these three, which of the carbocation will be more stable? So you will find in first one there is only one R group, either it can be alkyl or aryl. If it is alkyl, then it will show plus I effect, plus I, that is inductive effect. If it is aryl, then it will show resonating stabilization it will do for the carbocation. Similarly here there are two R groups, so inductive effect will be more. Then in the third case there are three R groups. Okay, so here the carbocation in the third case will be stabilized more. That means more the substitute, more is the stability. Okay, so if you see, more substitute carbocations are more stable. So here the stabilization order will be like this. The last one, which has all the three R groups, will be more stable than the first one. Okay, so when you are doing the numerical based on or reaction based on Pinacol-Pinacolone rearrangement, we have to first try to find out which of the carbon, that is first carbon of the diol or second carbon of the diol, is undergoing carbocation formation. So which is going to be more stable? Okay, so based on the resonance or based on the inductive effect we have to find out. For example, let us see first one and the second one. In the first case, let me show you, there are two possibilities. Either the first carbon is going to form a carbocation. Okay, so here the carbocation can be formed and your second carbon will carry OH group. This is your second carbon. So here it is CH3, PH, CH3 and CH3. Either this way or one more second option will be, second path if it follows, then carbocation will be formed on the second carbon and OH will be on the first carbon. Okay, so here it is CH3, CH3, pH and CH3. Then among these two options, tell me which is going to be more stable. Yes, students. So obviously in the first case, what is happening? First carbon where the carbocation is formed, there are two methyl groups these are trying to stabilize the carbocation. Whereas on the second carbon where the carbocation is formed, phenyl and methyl group. So there is a benzylic carbocation which is formed here. Okay. So obviously benzylic carbocation will be more stable than only the methyl carbocation. So this is going to be our second path will be followed, not the first path. Okay. So second path will be followed and then it will convert into pinacolone. Similarly, let us see the second example. Second example, it is an unsymmetric diol where it can undergo two-way first path and second path. First path again, what will happen? Let me show you. There is formation of a carbocation on first carbon. So if it is first carbon is forming a carbocation, then there are phenyl groups. Okay, pH. So there is pH. Then here it is CH3, CH3 and OH on the second carbon. Now if it follows the second path, then we will have carbocation here CH3, CH3, pH, pH and OH. So the carbocation has formed on the second carbon. Here the carbocation has formed on the first carbon. So path 1 and path 2. So we have to find out the stability of both the carbocation first. So in first case, in the first path, there are two phenyl rings. So two phenyl rings will stabilize the carbocation more. Okay, this carbocation will be stabilized more stable than the second path. So you will find that second path is not followed. Okay, second path is not followed, but path 1 will be followed and you will be getting the product of this one, that is first carbocation will be formed and then the migration will take place or rearrangement will take place. Okay, so student, you should always, when you are proceeding for Pinacol-Pinacolone rearrangement, you should first try to find out which of the carbocation is going to be more stable. Okay, by this way you can find out and then you can proceed for the ketone formation of Pinacol-Pinacolone rearrangement reaction. Now let us understand rearrangement of Pinacol-Pinacolone on unsymmetrical 1,2 diol. What do you mean by one unsymmetrical 1,2 diol? Unsymmetrical 1,2 diol means that the first and second carbon which carries OH groups will have different groups attached to it. For example, here you can see here the example which we have shown here on the screen. This is the first carbon, let us say, which carries OH group, and this is the second carbon which carries OH group. So it is a 1,2 diol. Okay, if you see on the first carbon there are two phenyl groups and on the second carbon there are two methyl groups. So if first carbon and second carbon carries different substitutes, then we will call such pinacol as what? Unsymmetrical pinacol. Okay, so let us see the reaction and find out what are the products. Now here first and second carbon, first thing is protonation will take place, then out of first and second which will undergo protonation, whether first carbon OH will undergo protonation or second carbon OH will undergo protonation, that we have to decide. Suppose first carbon OH undergoes protonation, okay, this carbocation will be formed because first carbon OH was getting protonated. That means I'll show the intermediate step here. OH, CH3, CH3, your pH and OH. So when this electron pair of oxygen is going to carry H plus ion from acid. It will become OH2O and oxygen will carry plus charge. Hydronium ion will be formed. Okay. Now to get this, what is going to happen? Water will get eliminated. Water will get eliminated, minus H2O. And you are going to get the first structure which we have shown here. That is, a carbocation is formed on first carbon. Correct? Now, as we know, we have seen that the carbocation should get stabilized and it should be more stable. Now you can see there are two phenyl groups, which that's the reason why they are going to stabilize the carbocation. Okay, so this structure 1 is more stable carbocation. Understood? Whereas if you see, if we are going to do the protonation on the second OH group, what is going to happen? Obviously the second carbon will get there is formation of carbocation on the second carbon. Now when there is formation of the carbocation on the second carbon, what is happening? There is only inductive effect from both the substitutes of CH3. So this will be less stable. This carbocation which will be formed after removal of your second OH group, it will be less stable. So this structure, that is second structure, is not possible. Okay, so this will not undergo the second step where there is no formation of a carbocation on the second carbon, whereas on the first carbon the carbocation is going to form and the reaction will proceed like this. Okay, and what you will be you are going to get the last step, there is rearrangement. So rearrangement, one of the methyl group, let me show with the blue color here, one of the methyl group will get rearranged. There is shifting which is going to take place, 1-2 shifting, and it will go and try to stabilize the positive charge. Okay, so this way you will getting the rearranged product and a ketone will be formed. So you know how the rearrangement takes place. Oxygen will donates its lone pair, shift its lone pair, and CH3 will be rearranged here, and this way you are going to get a ketone or pinacolone. Whereas your second type, or to get carbocation on the second carbon, is going to fail. This will not take place. Okay, this, so while doing the Pinacol-Pinacolone rearrangement, you have to remember this, that you have to first understand where the carbocation is going to form. Okay, so the carbocation is more stable as it is stabilized by resonance. Which one? Structure 1. Structure 1, carbocation is more stable as it is stabilized because of the resonance. There are two phenyl groups.